Thanks everybody for joining us today. Really excited about this demo. Renal and his co-founder Matt Gregory and we just spent the last couple of days building out an example of how to run an agent swarm using 1Password. So the example, or the demonstration rather, that we built here is running on the Autonomy platform using 1Password as the secure vault. So everything that you're going to see today is a real application. It's a real system. They are real agents that are getting spun up on Autonomy's platform. We're going to talk a little bit more about Autonomy's resource isolation architecture, their identity model in a little bit here. But yeah, everything is, these are real agents running in the cloud, interacting with real tool calls, interacting with a live 1Password Connect server. The only thing that's not real is that in order to create the demo here, we had the tool calls lie to the agents. So Renald's going to show this demo in a minute, but when he hits the lightning strike button at the top corner, that's the point at which the tool calls are going to start lying to the agents that are running, and it's going to lie in a way that makes it fabricate an actual incident with the infrastructure that they're diagnosing. So without further ado, Renald, take it away.
Thanks, Jeff. Super excited about this. So what we built is a on-call agent that behaves like an SRE. So its job is to monitor our infrastructure, diagnose problems when it notices something, and fix them, but do it in a way that is secure and grounded in human approval when it needs to access critical or credentials that can do some harm in the infrastructure. So that's the setup. So right now, it's waiting to be activated. And so I'm going to go in Cursor where we've written a skill to talk to this agent. So there's a Cursor skill that can communicate with the agent running in Autonomy. And I'm going to say, hey, activate on call. So I am a engineer on this team, and I'm saying I'm on call. So if you need some approvals, I can help you. So I say activate on call. And Cursor runs the skill and says, okay, I'm going to activate this. And it comes back with, okay, to monitor things on your behalf, I will need access to these credentials in 1Password. I'm only going to ask for read-only credentials initially, so I can keep an eye on things. So we'll say, okay, you have access to these read-only credentials. Okay, so credentials are approved, and it's saying, okay, you can go check things out on this dashboard. So I'll go over there, and now here we see that the on-call agent is monitoring infrastructure. At this point, I can go to bed. I've approved its read-only access. I can go to bed, and if things go wrong, it will tell me and page me. So it's now monitoring things. And at this point, as Jeff said earlier, we need to kind of simulate a failure. So we're going to do it by having some tool calls that mimic a failure in real infrastructure. So, and when I hit this button, it's going to notice, oh, something's wrong. There's an anomaly detected. There's like a cascading set of failures happening across a bunch of services, and the error rate is too high. So in response, it spun up 150 diagnostic agents. And the purpose of these agents is to go look at all these regions where all the failures are happening. So the incident spun up sub-agents for each region, and each region's agent spun up sub-agents for each service, and each services spun up a set of agents to look at the service from different angles. And so now the diagnostic is ongoing, and at some point it's going to figure out the reason and go from there.
That's awesome. Okay, so I'm going to take this moment while our agents go do their job and start figuring out what's going on here. Renal, I want to ask you a little bit about the Autonomy architecture. Specifically, I'm curious to hear about identity and how identity is actually built into the architecture here.
And good question. So in autonomy, all agents are modeled as actors, like Erlang style or Scala style actors. So these are really lightweight concurrent entities. So when we spun up all these agents, we didn't spin up 184 different containers to run these long-lived agents that need a workspace. We actually created all of them in a single container, and they're able to, because they're designed with this actor model in mind, they're able to work concurrently in that small infrastructure. And each agent is given its unique cryptographic identity. So it can authenticate using that identity, it can delegate work using that identity, and so forth. And each agent has a isolated workspace. So there's an isolated file system, an isolated shell for it to download things, run commands against the infrastructure, and so forth. And this identity infrastructure, because each agent has an identity and a set of credentials and that attest to its attributes, is really helpful in plugging into a system like 1Password, where we want to know who is accessing which credential, like which agent is accessing which credential. And so that's the plugin, but that's the overall identity picture in this and what we just built.
That's really great. So would you say that the autonomy platform is working within the confines of authenticated delegation? So you actually each sub agent that it's spawning off can be cryptographically rooted in trust.
That's right, and it's the who is taking what actions is attributable to a specific agent. We can diagnose their transcripts, and we can figure out why they chose to take a certain action. So it's the foundation of identity allows us to trace what is happening, why a certain decision was made, who approved that decision, and all of that whole life cycle.
That's awesome. That's really great. We've been thinking a lot about identity at 1Password over the last couple of months, especially in the context of agent architectures. I think the swarming concept is a really, really potent and I would say, yeah, it's a potent example of what we can do with agent architectures. I think what Cursor demonstrated a couple of weeks ago with building a web browser is just phenomenal, right? I think for them, it exceeded their expectations on a number of fronts, and it certainly exceeded my expectations too in terms of where we're currently at with these technologies. The thing that keeps me up at night is, how do we get these sorts of productivity boosts into the enterprise? How do we make this an approachable architecture for people to run at scale safely across, a diverse set of software engineers, right? Like not everybody has the same understanding of security controls as the next engineer. And so building on platforms like Autonomy that take a first class approach to building in those identity concepts and resource isolation concepts, that's super potent. So that's great.
Yeah, and I think what's happening is the reason Cursor had all of this success is because they used a general purpose long running agent with very powerful tools, a file system, a shell, etc. Right, and that's exactly what we did in this example. Is that each agent is using a highly capable model, Opus, Claude Opus, and it has a file system, a full workspace, and a full shell. So it's not it's not an agent that can take a few autonomous steps. It's an agent that can take each individual dot here can take complex set of autonomous decisions over a long period to achieve its diagnosis, and that's what it's doing over here. Okay,
awesome.
So what's happened now is it's come up with our swarm together, working together, has come up with a root cause. And this root cause is that a particular feature flag, when enabled a few hours ago or something, is causing problems and is causing the connection pool to exhaust and instead of runaway queries. So what it's doing is saying, hey, as a way to fix it, can you give me access to the database write credentials so that I can, kill all of these runaway queries? But I don't want to do that. I don't want it to kill these queries because it could affect like real customers and their workflows. So I'm going to deny this access. So I deny this, and a few seconds later it goes, okay, since you don't want me to do that, how about I just disable that feature flag and roll things back? And that seems like a safe operation. So to do that, it needs write access to our config service, which will disable that feature flag. And so I'm going to approve this. And then what we'll see is a remediation agent has spun up. And this remediation agent is going to work on fixing this problem. So this might be a good time, Jeff, to like look at what actions we approved in one password and what happened because of that. Our incident is resolved. It's back into the monitoring state, and the system is recovered. We've hit like a normal error rate, and we did that by disabling the feature flag. And most of this work was done by the swarm of agents that broke the job down into a set of parallel agents working in parallel on a complex diagnostic problem, figured out the solution, proposed the solution back to us. Me in this case, was able to approve the actions that need to be carefully looked at, and then or deny them. And once we did that, our incident was resolved.
Awesome. Renal, thank you so much for showing this demo and partnering with us on this. This was a ton of fun. Really appreciate it.
Thanks a lot. It was a lot of fun.